Welcome to writing equations of quadratic functions. This is very similar to 10, where you had to write the equation of a line y equals mx plus b, and you had to determine the value of the slope and the value of the y-intercept. Of course, we have different setup here, but very similar. So when we're dealing with y equals ax minus p squared plus q, we need values for a, for p, and for q. And the reason our x and y's stay as variables is because they represent the x and y coordinates, which we know there are an infinite number of possibilities for that, whereas there can only be one value for a, one value for p, and one value for q for each quadratic function. So we need to determine what a and what p and what q are. So one of the things that you can do, if you wish, right, you can do this, right? Once you have those figured out, then you're ready to write the equation. Not necessary. Now here's the nice thing, right? We already have p and q, right? So there they are. So p is 2 and q is -3. So what that means is that we need a. Well, our y-intercept doesn't give us a, but our y-intercept gives us an x and a y value, right? So we have p, q, x, and y. And for every, any equation that I can give you, as long as you know all of them but one, right, you can calculate one. So we have a y, we have an x, we have a p and a q, and we're going to calculate a. So y is 5, a we don't know, x is 0, p is 2, and q is -3. So we're going to solve for a by following order of operations. -2 times -2 is 4. Add 3 to both sides. And there we have it. And now that we have our three values, which again, if you find that helpful, go ahead, but I can see a, p, and q, and I am ready to write my equation. So y equals, here's my a value, x minus p squared plus q, which in this case is a negative. Okay, so now I know that, I've got the vertex again. So very similar setup. So I have my p and my q, and I have, excuse me, a different x and a y, right? So p, q, x, and y. And now we're going to do the same process. I don't need the original equation with all the variables in there. I always encourage students to put that down if they're having a hard time putting the numbers in the right place. So y, which is 7, equals a, looking for that again. This time our x isn't a 0, it's -3. P is -4, so because that negative is part of the equation, right, it becomes a minus -4, which will become +4 squared plus 1. Just double check that you could actually see all of that. We're going to solve for a again. 1 squared, oh, that's not difficult at all, so that was a nice one. And there's our a value. Y equals 6, x plus 4 squared. Just have to watch out for that negative and positive when it comes to our p value. And the last one, well, here's the graph, right? So we can determine the vertex, of course, by, in this case, looking for the coordinates of the highest point, since it opens downwards. So the vertex is going to be 0 and 3. Okay, so we have that p and q again. Once again, we need to know that value of a. Now we have 6 different ordered pairs we could use. I mean, technically we could use any point on this parabola, but there's no way we're going to be able to determine the correct x and y coordinates for that. So of course we want to use one of them that's clearly identified. So any one of those 6 will do. I usually try to deal with smaller numbers, so I'm going to choose 2 and -1, which is this one right there. You could use -1 and 2 if you want. And once again, substituting that in, -1 equals a, 2 minus 0 squared plus 3, -1 equals 4a plus 3. These are all nice numbers, but they definitely a can be a fraction, of course, we know that. -4 equals 4a, and there we go. So now we'll put that into, running out of room here. Let's see what we got. So y equals, now we knew it was going to be negative because we can see it opens downwards. So negative x minus 0 plus 3. Now you can put a -1 there. I think we've discussed that before. We don't need that. Almost forgot the negative. Plus 3. Because of course that's not simplified, but that is. And that's the end.